All right, let's talk about XSLT. So many times, when you find that you have folks that are interacting with one another and are sharing some data or sending some data across the wire, especially if you have companies that are working together, that are partners, right? Oftentimes they'll have to exchange data amongst themselves through processes that oftentimes do not share the same schema, right? Oftentimes, imagine that this was a Ford Motor Company, and Ford Motor Company has all sorts of providers, the ones that provide the tires and the windshields and the seats and all the instrumentation. And Ford Motor Company has all sorts of orders out to many of these vendors, and presumably has an automated process, right, that makes sure that certain orders come in a certain day. So because based on the production of the cars that are going out that particular month or that particular week or that particular day. Now these orders typically they need to are automated, right, and they have to agree on the particular schema or the particular meaning of whatever that order is, right? Oftentimes with no human interaction, and so they have to agree on what it means that I need certain type of tire, certain type of windshields and whatnot, and but oftentimes the infrastructure of these companies is not the same, right? Somebody might have Java, .NET, and some of them might have MySQL or their particular databases. And oftentimes the schemas are oftentimes not the same. The way I interpret and represent how I represent a particular car part might be different the way you represent your products. Yes, in Ford Motor Company, I might have a very detailed representation of what a car is, right? Whereas if this is Goodyear or Firestone, the representation of a car might be just an order number or some SKU, yes, or maybe a car and a model, right? But I might not care about all sorts of details about a car. So the schemas are different, right? And whereas a particular vendor might be very specific about their particular product. So their particular meaning or representation about the same concept might be different. So oftentimes we find that we need to convert or transform one schema into another schema, representing different domains, right? So XSLT is a technology that allows us to do this, right? To convert one schema representation into another equivalent schema representation, or one that might be very shallow into one that is very deep, right? One that might be very normalized into one that is very denormalized, or vice versa, right? Or maybe rename the attributes or rename of elements, or just shift things around. Very much like, for instance, you might have in SQL, in relational databases, you have a particular model, right, that is fairly normalized, and they have a relationship between them, but you want to consume it in a different way, depending on who your audience is, right? Or you might have certain queries that are very common that you keep using. So oftentimes you want to create a different representation of your data model, but not change the actual data model. You want to convert it. You want a transformation. So typically you would use views to do that, right? Views allow you to grab some information from this table, some information with that other table, join it together, maybe rename some fields, right? Maybe cast a couple of things, concatenate some values, right? And then provide a different view, that's what they're called views, right, into the actual underlying data model without modifying the underlying data model, right? So views are somewhat an equivalent or analogy of what XSLT might do, right? XSLT allows you to convert some data that is represented one way, represented and converted in some other way, right? Another example of where XSLT is fairly common is a is used in, for instance, in HTML. In HTML, we use XSLT, or a smaller version of XSLT, where we do some conversions of how documents are displayed. Right? So for instance, you might have HTML that has the main content or the main data that you want to display, but it has no information on the look and feel, for instance. Right? So typically we use other technologies to do that. For instance, cascading style sheets, CSS. So CSS is a form of transformation. Right? It converts different elements in the original HTML document. It converts it into being displayed in one way or another, right? It might convert it so that it's displayed maybe in horizontal or maybe in vertical format. It might display so that certain content is stuck to the top or stuck to the bottom, or that certain things are scrollable and certain things are not scrollable. Yes? So CSS is a form of transformation where you can convert the same identical input data, right, into multiple ways that it can be consumed, depending on how you want to display it. Different colors, different fonts, different layout, right? But the same input data, it's the same input HTML document. So style sheets or XSLT uses style sheet as the mechanism of transformation. So for instance, in CSS, what you can do is you have two main parts of a CSS, right? One of the parts is that it allows you to refer to the original document, right? It says, hey, you see that paragraph over there, right? Yeah, you see all those paragraphs over there and all those headings? Well, I want it to be all green, okay? So it has two parts. First, there's a part where you can refer to the original document, and the second part is what transformation do you want, right? The transformation is that, well, they used to be black. Well, I want them green. That's the transformation I want, right? Or they used to lay out vertically. I want to display them horizontally, right? And they used to be displayed, as a list. Well, I want it to be displayed as a top and bottom. Okay? So it has two of those parts, right? The reference of what the original content was, and the transformation that you want to apply. Make sense? Very much like views. Views do the same thing. Views first refer to the original elements, right? The original tables and the original rows in the select statement, right? You say in the where clause. In the where clause, you say, hey, you see all those documents, all those records in this table and that other table, where that field over there is the same as that field over there, right? See all those records, those 1,000 records? Well, I only want these fields and that field from over there, right? And convert this string, concatenate these two strings, and add this value over there, and now give me a new table, right? A fake table, right? A view. Right? So the same thing is you can refer to the original data, and then provide what you want that new transformation to look like. So XSLT plays that role, which is a very, very useful role in all sorts of ways. So first, let's take a look at some examples here. We have the original file that we're looking originally, where we have a list of students and their courses and their years of graduation and whatnot. And perhaps we want to convert it. We want to transform the document. And why is this not showing correctly? All right, there it is. So here's an example of what that transformation might look like. So here's this transformation is almost like a programming language, right? That you can specify what are those transformations. Remember, those transformations has two pieces. One is being able to refer to the original data, and the second part is what do you now want to do with that data, right? Like in the select and the where clause, right? In the where clause, you are referring to the original tables, how they relate, right? And then in the select clause, you refer to the transformations. Which fields do you want? Any new fields that you want to generate on the fly? Any concatenations you want to make, right? And create the new view, yes? Or in CSS, right? You have the left-hand side referring to the to these paragraphs and these headers, right? And on the right-hand side, what fonts and what colors you want to apply. So in an XSLT, style sheet does the same thing. So here's but a different syntax. SQL has its syntax, CSS has its syntax, XSLT has its own syntax. So it all starts with declaring the XSLT style sheet and the version. There's a version 2, and then inside you can configure a couple of things. You can configure what the output is going to be. You can generate all sorts of things. Typically, you transform XML into other XML, but there's no stopping of what can convert. You can convert XML into Word, XML into PowerPoint, XML into an image, XML into PDF. You can convert into whatever you want. Okay. Here is the most common is that the output is going to be XML. And I want to format it for my frontal cortex, so we're going to indent. We're going to add all sorts of white spaces so I can read the output XML. Then here is the first example of referring to the original document. What do you want to transform? What do you want to grab from the original document? Here we have the template match. That template match, graduating students. We are referring to the original document. The input document, there is a graduating students. There it is. I am referring to that root element. So that's graduating students. Down below, it says student. That means I am referring to all the elements that match student, in which there might be, well, here's one of them, student. There might be thousands of students. So this one template match student might be referring to thousands of students. What do I want to do with all those students? Okay. All right. So first, let's look at the first one, the graduating students. What can we do with that? All right. So what we're doing here is that for the graduating students. So that's the first half, right? We're saying, what are you referring to the original document, the input document? Now we're going to say, what do you want to do with it? What is the output? What is the transformation? So for that template, for that match, if the document matches this, which it does, I want to generate a brand new element called student names. Okay? So this is the output. And in the student names, I want to apply a template that is implemented elsewhere in this document. Now, there's another template down below, right, that selects student, which is actually defined down here. The content of the body of the student names is going to be whatever this generates, and we'll see that in a minute. Okay, so the output of I'm going to replace. Well, not in the original document, in the output document, graduating students is going to be converted into student names. So we already have a clue of what the transformation is going to do. It's just going to extract the names of the students. That's all it's going to do. I don't want the courses. I don't want the grades. I don't want to know when they graduated. Right? I don't want any of that. Right? I just want the student names. Yes? All right. Okay, so we have student names. And then we're going to apply whatever this one does. So let's go take a look at what that does. So in student name, in the student, we're going to generate a brand new element called name. And now this student is going to be applied to all the students. So there's going to be lots and lots of student elements that match that one template. Okay, there's going to be thousands of students that match this template. So this is going to execute multiple times. For every single student element in the original document, there's a brand new name element that's going to be generated. Right? A brand new name element. And the content, the body, so here's the opening name and here's the closing. The body, the value of the body is going to be whatever the S name used to be of the matching student elements. So the student element, if you remember, the original student element had an S name in it. See that? So this student inside has an S name. So I'm going to grab the value of Ian, right? And it's going to be the value of this brand new name. Okay? And the result is going to be, if this is the input, the output is going to look something like this. Right? So the student names at the top, right? And then multiple name entries for every single student that was in that original XML document, right? With the values of the username. Yes?
So is there something comparable for this for JSON, or is this sort of the advantage that XML would have?
JSON has something similar that allows you to convert JSON. Well, the thing is that in JSON, there's no schema standard, right? There's a couple of JSON schema competing standards, right? That's how to structure or describe the structure of a JSON object, because it's by definition JavaScript has been weakly typed, where attributes don't have a specific data type, right? But there's been competing now that we have TypeScript and ECMA is now introducing strongly typed languages, right? Version of JavaScript. Now we do care about this. So now there are competing ways to provide a schema for a JSON document, and also transformations.
Is this an instance where perhaps you'd be forced to work with the data in XML rather than JSON?
If schemas and transformation are important to you, yeah. Although JSON is going to have equivalent implementations of this, of schemas and transformations as well. Yeah. Right. So this is the output, right, of that one transformation, of going from this very, very verbose XML document, with lots of very nested XML document with graduating students and students having courses and courses having titles, right? All that is just being thrown away. The input XML document is left alone, and it generates a brand new XML document. In this case, it's a very shallow XML output document that has just a student name. That's all I wanted. Right? Again, these might be two institutions, and they want to consume the data differently. Very much what the view does, right? Our view might be a very normalized schema where you have students and sections and courses and enrollments and all sorts of data across multiple tables that we work really, really hard at normalizing it, but the registrar's office finds that very inconvenient, having to join all these tables, right? And they would prefer to consume the data and where they have just a spreadsheet where you have all the students across all the departments, across all the sections, across all the courses, right? They want to consume it in a denormalized fashion. Yes? Right? So, us DBAs, instead of ruining our very pretty and database has been very nicely normalized, what we do is we create a view for them to consume it in their terms. Make sense? So same thing here. Right? We are transforming one schema into another schema that might be convenient for someone else to have it in that particular format. Make sense? All right. We'll continue this a little later.